Hi my dear friends, welcome back to our YouTube channel. This is your YouTube channel. This is your ADC. Welcome back to ADC Maths. Classify the second order PDEs. Classify the second order PDEs. So how to classify the second order partial differential equations? The second order partial differential equations can be classified into three types. What are they? It depends upon the coefficients of the second order partial derivatives. For example, suppose when we have the z, so dou squared z by dou x squared is the A, and B is the coefficient of dou squared z by dou x dou y, and C is the coefficient of dou squared z by dou y squared. So z be the function of x. Suppose z be the function of x, then z with respect to x 2 times, that is the coefficient is called the A. Z with respect to x 1 time, y 1 time, that's first variable 1 time, second variable 1 time, that is the B. And z with respect to the second variable y 2 times, that is the C. So once we collect these coefficients A, B, C, particularly the second order partial derivatives coefficients alone, then find the discriminant value b squared minus 4ac. Suppose the b squared minus 4ac value is negative, then it is called elliptic equation, right? And suppose b squared minus 4ac is equal to 0, it is known as parabolic type. And b squared minus 4ac is positive, then we call it as it is hyperbolic equation. We have already seen that the one-dimensional wave equation is an example for hyperbolic equation. The one-dimensional heat flow equation is an example for parabolic, and the Laplace equation is example for elliptic. So what is one-dimensional wave equation? One-dimensional wave equation is dou squared y by dou t squared is equal to a squared into dou squared y by dou x squared. So this is the example for hyperbolic type. Okay. What about the one-dimensional heat flow equation? Dou u by dou t is equal to alpha square into dou square u by dou t square. This is the example for parabolic. And the two-dimensional heat flow equation under the steady state is often called as Laplace equation, that is dou square u by dou x square plus dou square u by dou y square is equal to 0 is an example for elliptic type. This is separate and exclusive video is already I made. I posted in our YouTube channel. Please, those who are missed, please go and watch that YouTube video in our YouTube channel ADC Maths. Now, in this video, I am going to consider your 6 problems under the second order partial differential equation, and I am going to classify what type of these second order partial differential equations with the help of the coefficients of the second order partial derivatives A, B and C to determine the b squared minus 4ac value. Based on this value, we can categorize into elliptic, parabolic and hyperbolic, depends upon the negative or equal to 0 or positive. Let us see the first sum. What's the first question here? Let us see. The first question is uxx plus 2 times uxy plus uyy equal to 0. So in this problem, u be the function of x and y, right? So first question, u be the function of x and y. So what about a? A is the coefficient of u with respect to x 2 times, right? So in this question number 1, the coefficient of uxx, the coefficient of uxx is 1. What is meant by b? B is u with respect to x 1 time and y 1 time, that is uxy. So what is the coefficient of uxy? That is 2. What about c? C is equal to dou square u by dou y square, because u is a function of x and y. So the second variable with respect to 2 times, that is y. So it is uyy. What is the coefficient of uyy in this equation? 1. So I found the a, b, c value. Now find out the b squared minus 4ac. So what is b squared minus 4ac? Is equal to b is equal to 2. So 2 squared minus 4 into 1 is equal to 2 squared 4, 4 minus 4, 0. So this is elliptic? No, is equal to 0. So parabolic. So this is the parabolic type equation. So this is the example for parabolic type equation. So the first question is parabolic type. Parabolic at all points x comma y. The second question now, here x into fxx plus y into fyy equal to 0, where x positive, y positive. The range of x and y is defined, right? Now, in this problem, what about f? F is a function of x and y, is right? Now, what is the a? A is f with respect to x 2 times, so that is fxx. What's the coefficient of fxx? That is x. That is x. X is the variable now. Let us see that. X is the variable. What is the range of x? X is always positive. And what about the b? B is f with respect to x 1 time, y 1 time. Unfortunately, we don't have such term. So that's why fxy is not given. So the b value is 0. What about c? C is f with respect to y 2 times. So dou square f by dou y square is equal to, that is fyy. So in this question number 2, fyy, the coefficient of fyy is y. So my c is y. So I found the a, b, c value. Now find out b squared minus 4ac. What's the b squared minus 4ac? B squared 0 minus 4 into x into y, because a equal to x, b equal to y. What about the x and y? X and y are positive. It is given in the equation itself. The range of x and y are positive. So x and y are positive. So xy is also positive. But minus 4 is negative. So b square minus 4ac is negative. So what's the name of this equation? This is comes under elliptic type. So this is elliptic type for all x and y are positive. For all x comma y greater than 0. Suppose any one is equal to 0, what happened? Suppose x is equal to 0 or y equal to 0, or both are equal to 0, what happened? This becomes 0. So then it becomes a parabolic. So the range of the variables, the domain of the variables is very, very important, because that only play a key role in this second order partial differential equation. Depends upon the range of the variables x and y, we may get the different types of equations. Okay. Now the third one, zxx. So in this third question, in this third problem, z be the function of x and y. So what about zxx? So zxx is a. So a equal to x plus 1. In this question number 3, a is the coefficient of x twice, and b is the coefficient of x 1 time, y 1 time. That is actually of this z means it is also z, right? Yeah. So z is a function of x and y only 1 time. So this is the b value. So b value is minus 2 times x plus 2. And what about c? C is z with respect to the second variable y 2 times. So it is x plus 3. So c is equal to x plus 3. Now find out the b squared minus 4ac value. So b squared minus 4ac minus 2 into x plus 2 to the 4 square minus 4 into x plus 1 into x plus 3. Let us abbreviate this. We get 4 into x squared plus 4x plus 4 minus 4 into x squared plus 4x plus 3. So I think so. It is a 4x squared plus 16x plus 16 minus 4x squared minus 16x minus 12. So 4x will be cancelled, 16x will be cancelled. 16 minus 4, 12 is 4. So b square minus 4, there is 4ac is always positive. So this is the example for hyperbolic. This is the example for hyperbolic type equation for all x comma y. For all x comma y, because it is the range of x and y is not mentioned here. So we say in generally for all x comma y. Now this is the fourth one. The fourth one I think so fxy. So this is the second order partial derivative, but this is fx first order partial derivative. So let us see that in the fourth sum. In the fourth sum, what about f? So f be the function of x and y. So what is a? A be the coefficient of f with respect to x 2 times. Sorry, there is no x 2 times, so it is 0. What about b? B is f with respect to x one time with respect to y. So I think so I have, so this is equal to 1. What about c? C is f with respect to y 2 times. Once again, there is no such partial derivatives present in the given PDE, so that's also 0. So once I repeat this, this is fx. What's fx represents? Fx represents dou f by dou x. This is first order partial derivative. But we are going to consider only the second order partial derivative. So that first order partial derivatives, don't consider it, simply neglect it. Okay? So we don't bother about this value. So a value 0, b value 1, c value 0. So what about b squared minus 4ac? So b squared minus 4ac is equal to 1 squared minus 4 into 0 into 0. So this is 1. So this is also positive. So this is also an example for hyperbolic type, isn't it? This is an example for hyperbolic type. And what about the fifth one? I think fourth one and the fifth one are more or less same type. Fifth one is u. U be the function of x and t. Please see that uxx is equal to ut. Uxx is equal to ut. So can we rewrite this by uxx minus ut is equal to 0? Yeah. Both are same. Uxx is equal to ut or uxx minus ut is equal to 0. Both are same, isn't it? Yeah. Now, what about a? A is the coefficient of u with respect to x 2 times. It is given, yeah, I think so. It is given here in this equation. So what's the coefficient of uxx? 1. So this time a is 1. What about b? B is u with respect to x one time t, but there is no such term. So b is 0. What about c? C is u with respect to t 2 times, but here only one time. This is the first order partial derivative, dou u by dou t. Please don't consider it, simply omit it. So there is no second order partial derivative other than this term. So only one term is given, right? So a value is 1, b 0, c 0. Now what about b squared minus 4ac? So b is 0 minus 4 into a1, but unfortunately c 0. So b squared minus 4ac becomes 0. B squared minus 4ac is equal to 0 means this is called the parabolic type. So this is the parabolic type equation. This is the parabolic type equation, isn't it? Now the last problem, something is interesting. What's the last one? The last one, let us see the last one. The last one is f. F is a function of x and y. F be the function of x and y. What about fxx? Fxx represents dou squared f by dou x squared, isn't it? What about fyy? Fyy represents dou squared f by dou y squared. So 2 times with respect to x, 2 times with respect to y. Okay, so what is a? A is the coefficient of fxx, 2 times with respect to x. So what's the x here? That is a is x. What about b? B is f with respect to x one time, with respect to y one time, but we don't have fxy. We don't have dou squared f by dou x dou y in this sixth equation. So there is no term, means b value is 0. What about c value? C is nothing but f with respect to y 2 times. So I think so I have, this is the fyy. So coefficient of fyy is 1. So c becomes 1. Now tell me what is a b squared minus 4ac? Now tell me what is b squared minus 4ac? B squared minus 4ac is b value 0, right? Z squared minus 4 into x into 1. So this is equal to minus 4x. Now the beauty is here, the answer is minus 4x. I think so. The second problem, I am getting that 4xy. But xy range is defined very clearly, both x and y are positive. That's why I am getting the output is elliptic. But this time the range of x is not mentioned in the given PDE. So we are going to classify this PDE depends on the nature of the variable x. So now I am going to discuss if x is negative, if x is equal to 0, if x is positive. So suppose if x is negative, what happened? Suppose if x is negative, minus 4 is behind the term. So x is negative, minus 4 is also negative. Negative into negative becomes positive. So if x is negative, this becomes positive. Positive means this becomes hyperbolic. So hyperbolic if x is negative. If x is equal to 0, if x is equal to 0, what happened? This value 0 into minus 4, 0. So then this becomes a parabolic. Then this becomes a parabolic. Right? Suppose if x is positive, so x is positive, but behind the x we have minus 4, this is a negative one. So minus into plus, negative into positive is negative. So then it is negative means this becomes elliptic. So the same equation can be classified into 3, depends upon the nature of x. If x is negative, this value becomes positive. So this becomes hyperbolic if x is negative. Suppose x is 0, this value becomes 0. So this becomes parabolic. And if x is positive, this product value becomes negative. So this comes under elliptic category. So the range, the domain, the limit of the variable is very, very important. In this second sum it is mentioned, but here doesn't mention, so that we can discuss the various possibilities of the variable x. If x is negative, what happened? If x is 0, what happened? If x is positive, what happened? So this is the very interesting idea in the second order partial differential equation. So how to classify the second order partial differential equation? We only pick the second order partial derivatives coefficients. A is with respect to the first variable twice, B is with respect to first variable one time, second variable one time, whatever may be the variable, either x, y, u, v, x, t, whatever it is, right? And C is second variable 2 times. Then find the b square minus 4ac value. Suppose the b square minus 4ac is negative, it is called the elliptic. Suppose it is equal to 0, it is known as parabolic. If it is positive, it is called as the hyperbolic equation. Okay, thank you so much for watching our YouTube channel ADC Maths. I'm signing off. Take care. Bye.